Okay, so we are pretty much done with unit 4. We are starting unit 5, which is foundation of geometry and trigonometry. And okay. So we are starting with foundation, unit 5, which is foundation of geometry and trigonometry. So basically we will start with the basic understanding of geometry that we have learned in the previous classes. Take it to the next level where we'll talk about volume, surface area of different shapes, different 3D objects, and then let me go through all that I had mentioned, and then we will continue to trigonometry in the coming classes. So from today's coverage point of view, so we are starting with basic geometry, where we'll talk about surface area and volume of 3D objects. We'll try to find out the volume of shapes that cannot be measured. Let's say if I say find out the volume of this pen. It's not as easy as we want it to be, right? I mean, it's not a cylinder, it's not a sphere, it's not a pyramid, it's not a cuboid, cube either, right? Hey Vishal.
Today I'm gonna have to leave early, like in 20 or like 30 minutes.
That puts extra pressure on you. You'll have to watch the video of the class later so that you can catch up on whatever you would miss by leaving early. Okay.
Yeah,
all right.
I'll watch it.
Yeah, sure. All right. So let's start with something that you guys already know. Hello, Shravya. And then we will keep digging deeper into it. So let me ask some lame questions to you guys. What do you understand by volume? In the easiest possible way. Treat your teacher like a 3rd, 4th, 5th grader. And can you explain that to me and tell me what exactly do you mean by volume of any object? Any object. Yes, Dave.
Is it volume like how much like a liquid it could store, like water, for example?
Little louder.
Like the volume could be like when we say like, oh, this shape has a volume of 3,000 or whatever, it's like saying like that's how much water we can store in this shape.
You are pretty much there. Let's hear everybody else. Let's see what Shiv has to say. Yes, Shiv.
Volume is basically the space that an object takes, the amount of space an object takes.
Okay. Oops. Okay. Praneeth, what is your definition?
The same thing he said.
Same thing, copy paste.
It's the density of a shape.
These are relatable, but I'll put it a little differently. Let me hear everybody. Hey, Tanu.
Hi.
So, quick roll call. We have Shiv, Dhanvin, Dev, Praneeth, Riya, Ritika, Shravya, Shriyan, Tanu, and Vishal. And here in the classroom I have Anjani with me. Sorry, so some of Anjani's friends who are supposed to be here, I think they are still enjoying the long weekend with family. So that's why they are not here, but don't worry. Okay, so some of you said that volume means the amount of water it contains. Look at my water bottle. It contains water up to here, but when I'm counting the volume of this guy, I might count this thing also. I might count the space that it takes also. So, in the simplest possible way, volume of any object is the space taken by that. Imagine me being, let's say, 800 pound in weight. Imagine how big I would be. Humongous. If I'm that big and you find 20 people of my size and you are trying to fit everybody in this classroom, do you think it'll be doable? I mean, only Anjani knows how big the classroom is right now. So I'm just asking this question to Anjani that, okay, if you have me who is 800 pound in weight, so I would be big, So 20 people of my size, can they fit in this classroom? Or maybe you can push a little bit of adjustment, you can make them fit. How about 50? Impossible. 200 out of question. Yeah? So in simplest possible term, if you want to define volume of any object, look at this wire, look at this, what do you call it?
I forgot.
Protector?
Protractor.
Protector? No, protector is the one that has where you can hook a pencil to it and then make circles. This one, semicircle or something. Okay, anyway, doesn't matter. Out of syllabus. Look at the volume of this pen. Look at this thing. Look at my dry eraser. Everything needs some space to fit in. If I have this wire or things of this size to be fit in this classroom, I can probably put thousands, maybe 20,000, 50,000 of that. But can I have 60 students sitting in this classroom? Probably not. Because every student will need certain space. And the space taken by that object is called the volume. Okay? Now, if this is what I'm concerned about when it comes to finding out the volume, I might say that, okay, the amount of water it can contain. That will precisely give me, a very high level view of how much volume it has. But then, that's only a possibility when you talk about something which is hollow, which has space inside it. But in simplest possible term, volume is the space taken by any object. Now let's look at little mathematically. Let's say you have a big container like this. Okay, and let's assume this to be a swimming pool, and you have water filled up to here, and then you guys lift me and put me inside the swimming pool. What happens that I being not so light, the water level jumps from here to here. So the amount of water, how much water level moved up is actually is a function of how much space I was taking. So more you tried pushing me in, more I got immersed into the water. My body displays the equal amount of water, and that is how this level went up. Yeah? Am I making sense so far? Okay. So volume of any object is the space taken by that, whether that we are talking about the space taken by me inside the swimming pool, or be it by the space taken by me and everything else that we have in this classroom. Everything is taking some volume of the space. Now this is the theory of it. Now I have beaten this concept so much so that now at least whenever you hear the term volume, first thing you'll think about is the space taken by any object, be it solid, hollow. Now let's look at different type of things that we come across, and we will look at what is the volume of those objects, and then we will look at how do we find out the ways to calculate that. What do you see on the screen?
Prism?
What do you, okay, prism, okay. Any other name that you guys can think of?
Cube.
This one is a prism or rectangular prism, or I will also call it a cuboid. This one is a cube. Why? Because if you imagine this as an object, the base of that is a square. Okay, so meaning your length and width both are of same size, same value, and then you extend that upwards in the third dimension, and the height is also same as the length and width. Okay, when length, width, and height all the three are same, you call it a cube. Here, if you compare this with the object that you see here, which you call as prism or a cuboid or a rectangular prism, it's actually look at the base of it. That is a rectangle which you are extending upwards, and that this is length, this is your width, and this third dimension that you added is your height. Okay, so every 3D object, D stands for dimension. When you are looking at a rectangle, you are looking at only two dimensions, one in the horizontal axis, one along the vertical axis, x and y. Here you are looking at three dimensions, length, width, so x and y, and there is a third dimension, that is z, that is added. So that's why it's called 3D objects, which have three dimensions, length, width and height. If you're talking about rectangle, square, trapezoid, circle, triangles, kite, rhombus, everything is two dimensions. When we talk about 3D objects or solid shapes, it has three dimensions to it. If you look at me as an object, I'm a 3D object. I have length and width, and then I have height. Yeah? All of us are 3D objects, which you cannot draw on a piece of paper. You cannot draw my entire features on a piece of paper. I mean, you can simulate it, you can make it look like a 3D object, but it is still using two dimensions, length and width. Okay? Is that understanding okay so far? Riya, Tanu, Shravya? Alright. 3D objects we have talked about, we deliberated enough about the volume. There's one more thing that we talk about when it comes to 3D objects, that is called surface area. Any simple point of view around surface area? What is the surface area? What do you mean by that?
I think the area is for 2D objects and surface area is for 3D objects.
Mathematically, absolutely correct, but then I want a layman's definition because that's what I remember better. You can give example also. Yes, Ritika.
Isn't it like the surface area, like for like a 3D shape? It's like the area, like the outer surfaces, like around the whole thing.
Exactly. You are getting in the right direction. You're going in the right direction. Anjani, yeah, point of view better. No surface area. Okay, Pradeep.
The surface area is the area of all the different faces of a 3D object.
Okay. I heard some of you, Riya, Tanu, any point of view. And guys, don't be shy, okay? Give your point of view. It's okay. Read right or wrong, doesn't matter. Riya, any familiarity with surface area? Yeah, Vishal.
It's just the area that all combined of all the sides of the shape.
Okay. Yep. Alright, so let me not bother you guys more. Surface area. Yep, yes, Riya, you conclude your chain of thought. Yeah, tell me your point of view first.
The surface area, I mean, it could be like all the sides of the shape showing, but like, say if it was like a building, and you would like get the surface area, you wouldn't get the bottom of it because that's not on the surface, right? You would only get the top. Right?
Yeah.
So it kind of depends on the problem.
Exactly. No, so problem, I'm not worried about the problem right now because problem is not a problem right now. We are only trying to focus on building the right understanding of things. Now, I promise I'll give you the worst possible example in this class, which you will never forget. Now, surface area. Who is the mother of maths? English. If we know English well, we can relate it to the math concepts. So surface area. Whatever is on the surface, the area of that, okay, is surface area. Now comes the worst example that you guys can think of. I'm sure Praneeth has heard this before. Let's say you don't like your teacher at all and you want to color me green. How much of paint you would need would be a function of how bulky, how big I am. Meaning, see, if you have to color me green, you would not want to break my hand and then color inside. You will only color the surface of me, which is visible to everybody. So surface area is everything that is visible, that is on the surface. Surface area of this water bottle is the surface that you are seeing from outside, which includes maybe here also. If I'm counting the whole thing, unlike a building example that Riya was given, was giving, I'm counting this also. If I have to color this water bottle, I'll color everything that is visible from outside, which is on the surface. So that is how you will relate it. Surface area is area of the entire surface that is visible to us. Okay. So now if you plan to color me green or blue or red or pink, whatever color you guys like, you'll have to figure out how big your teacher is and how much paint you would need. So surface area helps you in deciding that. Let's see if I want to color this classroom. What would I color is? The entire surface. I will measure all the area that is visible here and then say, okay, fine, this area is, let's say, 500 square feet. And then, okay, 100 square feet needs this much paint, 500 square feet would need this much paint. That is how we'll use it, right? So surface area and volume, these are the building blocks of geometry when we talk about the 3D objects. Okay, there is no third thing that we will learn. Surface area and volume, that's what we'll deal with for next 20, 30, 40 minutes. Now let's look at all the shapes that will come across and let's see how much we remember. Because all these things that we're going to talk about, you would have heard this or learned this before. We are just going to do a recap and see how comfortable we are with applying those concepts. Let's look at, this is nothing but a rectangle, the easiest possible shape that we all have heard about. It has two dimensions, length and width, x and y. I'm adding third dimension to it. I added height also. And there is no relationship between length, width and height. It could be all different. Nobody is stopping us from doing that. Nobody is putting any constant here as well. So this is called a cuboid, or since the mother of this is rectangle, so it's also called rectangular prism. Okay. So cuboid or rectangular prism. Now the second basic shape that we are all aware of is square. Okay. So if I extend this also in the third dimension, meaning I also add height to it. So length and width is anyway the same because it's square, and height also I added as much as so that it's same as the other two sides. Okay. So this is your cuboid, this is your cube. Let's double click on these two. How much will be the volume of a cuboid? Any thoughts? Any idea? Any formula that you guys know about it? Yes, Pranit.
Length times height times width.
Length times width times height. So it's like this. I have an example. Let's see, what you guys see is a rectangle. Okay. Now, so far it was just a rectangle. I started adding rectangle after rectangle after rectangle after rectangle, and that is how it became a notebook. I can call this guy a cuboid. Okay. Now, more the pages you add, much bigger it will become, more space it will take, higher will be the volume. Relatable? So, area of a rectangle is length times width. You are adding a third dimension, and how much the volume would be a function of area of the base times the height. So that's what Pranit was saying. That is length times width times height. Higher the height, more the volume. Again, more the base, more the area, more the volume. Okay. So these three things define the volume of your cuboid. And I'm sure you guys have learned this. I'm just double clicking on this to make sure that we are aware of the formulas that we have learned in the past. Now, if I say find out what is the volume, what is the surface area of this guy? What is the surface area of a cuboid? How would you find it out? So let me make it a little easy. This is length, this is width, and this is height. Yeah. Yes, Ritika.
Wait, so like, wouldn't you find like because like the area of like one of like the squares and then multiply it by 6 because it's like 6 sides? Because
No, that might apply here, not here.
oh,
Because your cuboid stare this object very carefully, okay? Do as much stalking of this object you can do. Yes, Praneeth.
For a cuboid, the surface area can be found using 2 times length times width plus 2 times length times height plus 2 times width times height.
Yeah, that's a mathematical way of looking at it. Now if you look at this object carefully, let me show you this object. This is a cuboid. This was a rectangle. I added height to it. Now it's a cuboid. Okay. So if I'm trying to find out surface area, I'm trying to find out this area, the area in the back, then this area opposite to that, this area, and the area opposite to that. Yeah. Am I going at an okay pace for everybody? Yeah. Fine. So every side that you see, there's a corresponding opposite side, and they are exactly the same. Let's say this is my length, this is my width, and this is my height. Okay, remember this. This is length, width, and height. This side is height. This area is length times width, and I have a copy of that in the back. So 2 times length into width. Now this one, this is my width, and this is my height. This area is, again, this is also a rectangle, 2 times width into height. 2 times of this also, because I have something in the back which I am not able to see right now. And then the top of that. This is, oops, we counted this, right? Length and width, okay. And this is height. So we calculated this one. So width into height. Now we have this one. So which has length into height. Okay. So this is length into height, and again I have 2 copies of that, one in the back, one in the front. So here, if you see, you have 6 sides, this side, this side, this side, this side, this one, and one in the back, which I'm not able to show you guys. So total 6 sides, and they are all in pairs. So basically you have 3 pairs of sides. First pair of the side is made of length into width, and I have 2 of that. Second pair of sides is made of this is length, this is height. So okay, this is length and this is height. Length into height, 2 times of length and height. This one. Then this is width and height. So 2 times of width and height. And then you have this one, which is length and width. Again, 2 times of length into width. So you will see that, okay, since you have length, width and height, there are 3 pairs, and every pair, one is made of length and height, one is made of width and height, one is made of length and width. So that is how Praneeth was saying that 2 times length into width plus width into height plus length into height. You can memorize this formula, or as long as you paint this picture in your mind, how a cuboid looks like, as long as you are clear about it, this formula you don't have to memorize. It will be very relatable. And I'm pretty sure Praneeth did not memorize this formula either. Right, Praneeth? Because I'm not a big fan of memorizing formula. I'm a fan of deriving formulas.
No, sir.
Yeah. Okay, so this is on the cuboid. Is everybody clear? Poor girl, she's the victim of being alone in the class. Every question I ask, I come to Anjani. Okay, but yeah, everybody, yeah. Vishal.
I need to.
Yes, beta, you can carry on. You have some extra responsibility on your shoulder. Watch the video afterwards. Yeah. Alright?
Thank you.
So cuboid we looked at. Now let's go to the next one. Are we okay to go to the next one? One, yes. Okay. Now cube. What is that you see here? As long as the property of cube is deeply stuck in our memories, okay? That okay, cube when I'm talking about cube, it originates from a square and has the same length, width and height. That means every side of this one would be exactly same. This is length into width, again length and length, same. This is, let's say, width into height, again both are same. So this side and this top one, all are same. and we have 2 pairs of that. So basically we have 3 pairs of equal area. Yeah. So 6 times of, yeah. So this becomes your surface area. 6 times of side square, because all the sides are same. So only difference you have to keep in mind is cuboid has length, width and height that are different. Cube has length, width and height, all are same. Cube originates from a square, this originates from a rectangle. Yeah. Can somebody tell me on the fly what is the volume of this guy? Anybody? Real quick. Praneeth, not Praneeth, right here, hold it. Praneeth, you hold it. I want to see if anybody else can think and give the answer without me teaching it. Anybody else? Guys, don't be shy. I don't look scary by any means. I promise. Ria, Dave, Shravya, anybody? What is the volume of a cube? You guys are not trying. You guys have to think out of the box. Make attempt, go wrong, that's okay, safe. Yeah, go ahead.
For a cuboid, the formula for volume would be length times width times height, and for a cube it would just be the side cube.
Okay. Yep. Ria, go ahead.
It would just be like x, like whatever number is cubed, x cubed.
X cube, yeah. Yeah, Dave. Same thing?
Yeah, same thing.
So basically cube has all the dimensions same, length, width and height are same. And this looks like a sibling or maybe a cousin of this guy, right? Has something, everything similar, right? I mean, this is rectangle, this is square, that's it. Here you have length, width and height. I will here also say length into width into height. And then I realize, okay, length, width and height all are same. Why to write 3 different things? I'll say length into length into length, or width into width into width, or height into height, whatever I like. To generalize this, I'll say side cube. Yeah? And why I'm stressing on this is, remember this now. If you are trying to find out the volume of any symmetric object, when I say symmetric, I'm not talking about something like this. I'm talking about something like this, which looks similar from top to bottom. When I take cross section of that, every cross section is the same. Yeah? So here, what did we do? We found this, let's say this is the base. Base is what? This is length times width, and then multiply that by height. Here you have, this is length, this is length, this is length. Again, I took the base, length into length, times the height, which is again a length. See? So now, other trick or concept that you would want to keep with you is, if you look at any symmetric object, and again, when I say symmetric, meaning it's something which is predictable. It doesn't change. Every cross section that you take is exactly the same. Then you will call it a symmetric shape or symmetric object. And then if your object is symmetric, then you just find out the area of the base and multiply that by height, that will be a volume. Yeah? So that's what we saw here. Now I'm going to, and sorry Praneeth for stopping you, because I knew you have the answer, you have heard me before also. So I was sensing that you are ready with the answer. I just want to give a chance to everybody else, okay? Don't worry about it. Now, picking the third object. What is it called? Cylinder or right cylinder, whatever you call it. What is the property of this guy? This is made of circles. So you had one circle. You kept on stacking circle after circle after circle after circle after circle after circle. Or if you guys have seen bangles at home, right? Mommy using bangles or the ladies in the family. So if you stack all the bangles together, that makes a cylinder. Yeah. Or You can visualize this as it's something made of too many circles stacked one after another. Same thing if I say find out the volume of this right cylinder, how much that would be? And tell me a story. I will tell you guys, I'll go in a sequence, okay? With a reason, okay? I'll start with Ritika. Yeah, Ritika, go ahead, Ritika.
Wait, so the volume of a cylinder is like pi r squared times h?
Okay, I don't know. Praneeth, do you think that is right?
I have pi r squared times h.
Okay, so that's what Ritika said. I wanted you guys to validate it so that you don't rely on me alone. Okay.
That's
Okay, so I was kidding, Ritika. So this is same thing. Yeah. Like I said, if you're talking about any symmetric shape, find out the area of the base, and your area of the base is nothing but a circle. Yeah. Multiply that by the height. That becomes your volume, pi r square h. Dave, was that your answer as well, beta?
Yes, sir.
Okay. Now, so volume is okay. If somebody says, I have a water tank which is a right cylinder, find out how much volume it has, how much water it can contain. You guys know how to find out the volume of this. You will say, okay, tell me the radius and how tall is the cylinder, and I will find it out for you. Tanu, Shravya, you guys are very quiet. All okay? Okay. And please feel free to participate, okay? More you participate, I don't know about your confidence, I get more confident actually. When the kids participate, that boosts my confidence level, okay? So please participate as much as you can. Question, answer, be it right or wrong, that's okay. This class doesn't give you any grade, okay? So let's enjoy our mistakes also. So this is the volume. Now, if I say surface area, meaning I have a water tank, I want to color it completely. So I'm trying to find out the surface area of the water tank, which is a right cylinder. And I'm counting the top and bottom as well. Now Anjali is laughing. Earlier I was trying to color myself, now I'm trying to color the water tank. So that's why I say thinking, why this gentleman is trying to color everything. Okay, so let's come to a serious discussion. So I'm trying to find out the surface area of this water tank, basically. How would I find it out? Any thoughts around this? How would you derive it? Yes, Praneeth. Tell me half of it. Or okay, let's do one thing. Let's do some role play. Let's see how Praneeth explains that to all of us. Yes, Praneeth, go ahead.
So a right cylinder consists of two circles and a rectangle, which has been curved around the two circles as bases.
Mm-hmm.
So to the surface area, you would get the surface area of each circle, which would be the 2 pi r
Square?
Yeah. Yeah, and then you would do you would find plus this area of a rectangle, which would be length, which in this case would be the circumference of the circle, which would give you one side of this rectangle, and then the height of the cylinder is the other part of the rectangle.
Okay, so let me make it a little easy for everybody to understand. Thank you, Praneeth. So you gave us a good starting point. I'm just trying to make it a little easy for everybody. This is a cylinder. You see a circle, and there are so many circles, thin circles stacked one after another to make this right cylinder. Does everybody agree to this being a cylinder? Ritika, Riya, Tanu, Shravya, everybody? Yeah. All right. So this is a right cylinder. So if somebody says find out the volume of it, what you guys did, found out the area of the base, multiplied that with the height. This is a height. Yeah? Anjani here? Okay. So this is the area, and you multiply that with the height. That gives you the volume. Now we are trying to find out the surface area, meaning like what Praneeth said, there are two circles here, this circle and this circle, and there is a curved surface that you see. See, I am rotating this cylinder, okay, and you are trying to find out the entire curved surface area, okay. Praneeth was saying this is a rectangle. Some of you might find it difficult. How? Where did it become a rectangle? See? This became a rectangle. That's what Praneeth was alluding to. Okay? Again, I'm folding it to make it look like a circle. So, everybody in the world knows how to find out the area of a rectangle. You'll say length times width. What is length? What is width? If I'm opening it, I have this, let's say if I call this as a width, this could be length. If I call this as a length, this is a width. Whatever it be. I'm able to find out, see, one side I'm able to find out. If I open it, the height is one side, be it length or width. What is the other side? This side. Look at it carefully. See, I'm playing with this at this age. You guys have to play as well. So, what do you see here? This perimeter became side of the rectangle, one side of the rectangle. Height was there in place. See, this cylinder, when you are opening it, becomes a rectangle, and that rectangle has two sides. This is, let's say this is width, which is same as the height of the cylinder, and this is nothing but the perimeter of the circle that you had in the cylinder. This perimeter opened to become one side of the rectangle, isn't it? Praneeth, am I saying it right? Is everybody able to follow me? This was your cylinder. You found the area of this side, which is fine, a circle. Area of this side, that is also a circle, that is fine. You're trying to find out the curved area of the curved surface, and that you cut it open to find out this area, and that is like a rectangle, like what Praneeth was saying. But this rectangle has two dimensions, length and width. This is nothing but the height. So one side is same as height. The other side is nothing but the perimeter which got opened. Ria, is it making sense better? Yeah? No? Challenge your teacher, it's okay. You can say, sir, you're not making sense yet. I will try my best. Dhanvin? Make sense? Yeah? Make sense? Tanu, are you with me, beta?
Yeah.
Yeah. So basically this curved surface of the cylinder is nothing but this rectangle which has two dimensions. One side is the height of the cylinder, and other side is the perimeter of my original circle of the cylinder. So this thing was opened, and this is nothing but my perimeter. The perimeter of a circle is 2 pi r. So that became one side of the rectangle, and this height. So length into width. So length is, let's say, 2 pi r, the perimeter, and then the width is nothing but my height. So it became 2 pi r square plus 2 pi r h. Here you can take 2 pi r common, it becomes 2 pi r into r plus h. We all can memorize this formula saying surface area of a cylinder is 2 pi r into r plus h. Or forget about it. You know that there are two circles, top and bottom of the cylinder is 2 pi r squared, that is the area, and then the area of the curved surface, which is becoming a rectangle by opening this one, which has one side as the height and other side as the perimeter of the circle, 2 pi r into h, length into width. Yeah. So this became 2 pi r into r plus h. Is everybody with me? So one concept that we want to take away with us is, if you are talking about any 3D object, any symmetric 3D object, the volume of that will be, take the area of the cross section, multiply that by the height. Be it a cylinder, volume is pi r square times the height. Be it a cuboid, length into width into height. Be it a cube, length into width, both are same, so length into height. Again, height is also same, so length into length. Now we are talking about the surface area. In case of cuboid, you saw that you have 3 pairs of equal sides. So 3 times, one side is length times width, second side is width times height, third time is length times height. That became your surface area. Again, you don't have to memorize all these formulas. I am not a big fan of memorizing formulas. As long as you keep on recalling what the basic concepts and the properties are, you will be able to derive it. It doesn't take more than 30 seconds. Memorizing might take 20 seconds and forgetting might take 20 more seconds. And then the stress that it creates, that might take another 30 seconds of your life during the exam. Instead of wasting that 1 minute, you can derive it on the fly. It's super easy. As long as you can picturize it, you'll be able to derive it. Yeah? Is everybody okay with that? And whoever speaks less becomes my obvious pick. Tanu, Ria, everybody okay with that? Savya? Yeah. Dhanvin, okay? Okay. No, so again, I'm not trying to bother anybody in particular, but yeah, just want to make sure that every child here in the class is with me. Yeah? Post lunch might get a little sleepy, and I'm just trying to wake everybody up. Alright. So this is on the basic concepts of the very commonly used 3D objects. Let's look at some of the problems that we wanted to solve. Okay. Now, before I jump onto the problems, let's look at 2 more concepts. One is finding the volume of uneven objects, and second is congruence, similarity, and angle related properties. Okay, so we started this class with that thing, right, where you guys were trying to dip me in a swimming pool, right, to find out my volume. That is the concept. Though I said that in a lighter way, but that's a very commonly used concept that we use for finding out the volume of anything which is uneven. Let's say you have to find out volume of this dry eraser. Trust me, not even Sir Isaac Newton has derived the formula for this. There is no formula that exists. What you will do is, if you have to find out the volume of this particular object, what is the name of this object? I don't know. Mathematically, is there a name? I don't know. What I will do is, I'll just take a big tank, and mostly measuring tank, let's say. Okay. If it's up to here, it says 100 cubic feet. Up to here, 50 cubic feet. Up to here, let's say 20 cubic feet. Maybe this is half a cubic feet or something like that, even less than that. Or let's say, whatever it be. Let's say I fill water till here. I have a container which has water filled up to 50 cubic feet. If I have to find out the volume of this guy, what I will do is I'll simply dip it in this water and leave it there. It will displace equal amount of water as the volume of itself. So let's say after dipping this water rises to, let's say, 55 cubic feet. Okay, that is the volume. 55 minus 50, 5 cubic feet is the volume of this guy. You don't really have to scramble to figure out formula for any nonsensical object like this. Okay. Don't worry about this. This is a very commonly used concept. That's why my jokes are also very valuable. Okay. So the example that I was giving you, there was a reason to it. Okay. I mean, you don't have to respect my jokes. My jokes are very stupid at times, but yeah, there was a reason why I was giving that example. Okay. So any uneven shape object that you cannot define mathematically or in terms of geometry, and if you have to find out the volume, dip it in water with a measured scale and then see how much it moved. Okay. Now the next concept that we are going to talk about is congruence and similarity. Let's look at the concept first, then we'll look at how many problems we want to solve. Okay, let's do one thing. Let's solve few problems, and we'll not spend much time, and then we will go to these concepts. So let's pick one problem. Okay, the problem is the volume of a right circular cone A is 4 cubic meter. This is a right circular cone, like a funnel, okay? Is 4 cubic meter. The volume of this is 4 cubic meter. What is the volume if in cubic meter of a right circular cone with 2.5 times the radius and 7 times the height of a cone? Okay. A volume of a right circular cone A is 4 cubic meter. I think we have not covered this one, okay? We have not covered how to find out the volume of a circular cone. We'll cover that in the next class, okay? Then we'll be able to relate this problem. Let's skip that one. Let's look at another one. We are given a formula V equal to 4 by 3 pi r cube. The formula gives the volume V of a sphere with radius r. What is the volume in cubic inches of a sphere with a radius of 6 inches? Do you guys want to solve this one? Alright. Now let me read the question, okay? We'll see if there is any merit in this problem, okay? This was picked up from Khan Academy itself. This is the formula given, volume equal to 4 by 3 pi r cube. The formula gives the volume V of a sphere with radius r. This is the radius and this pi. This formula gives the volume of a sphere with radius r. What is the volume in cubic inches of a sphere with radius of 6 inches? Okay. I don't want anybody to solve this, but tell me with this problem, do you see a problem? This is the formula given to us, okay? And see again, I'm not trying to show any disrespect for anything, but what I'm saying is, this question is very lightweight. This doesn't have enough merit for you guys to solve it actually. It has given the formula. It says this is a formula for calculating the volume of a sphere, and where r is the radius and v is the volume, and you are given the radius of 6 inches. Find out the volume. Yes, Shreya.
Wouldn't you just plug in 6 over there?
Exactly, that's what I was saying. So this is like, you are given a formula, and it says this is the radius, apply it and calculate it. That's why I was saying that I was not super excited to solve this problem. Neither I wanted you guys to spend your time and energy solving this problem. This is one of the easiest problems that you could come across in your SAT exam, and you will just have a breeze. Okay, it will be very easy to solve. Yeah. Does everybody believe so, or you guys would want to try this out? No? Okay. So I think the questions that I got for whatever I wanted to cover today, those are very lightweight ones, and the question related to right circular cone, that volume and surface area are not covered today. So we'll discuss that in the next class, and then we'll come back to this. In the meantime, we want to cover or brush up on our concepts related to congruence and similarity. Who can tell me what do you mean by congruence? Yes, sir.
Isn't it when like a shape is like the same shape as like another, no, like the same size or something, or like?
You are going the right direction. Let's hear Dave also. Yes, Dave.
Well, incongruence, like when the shape has like similar characteristics, like let's say the sides on it are the same, or like an angle on it are same.
Okay, let's see what Dhanvin wants to say. Yes, Dhanvin.
One or more sides being the same, like as the on another side.
Okay, Pranit.
Congruence is when two shapes are the exact same.
Yes. See, what am I doing right now? Look at my hands. Thankfully, they're exact copy of each other. Okay? by God's grace. This is called congruence. Meaning when two shapes are exactly the same, they have every matching property. There's no doubt about anything being different. If I say this triangle and this rectangle are congruent, you will say, sir, please take a hike. They cannot be congruent. They have to have every matching property. Now when you look at any object for that matter, what is property? Let's say if you have to define me as a teacher, what are my properties? Somebody who wears glasses, has less hair, a lot of hairs are grey, this is my height, I speak very loud. Yeah, I mean some of the things that will define or differentiate me from others, right? Same way, when you talk about any shape, what are the properties? Anything and everything that defines. If I'm looking at this triangle, what are the properties? This side is one property of the triangle. This side is another property. This side is another property. These are three properties. Then you have angles. And three angles are three other properties. Why these two triangles are different? Because they don't have matching properties. Here you have different angles, here you have different angles. They are not matching. So, congruence is the mechanism which establishes the exactness or match between two shapes. These two cannot match, they will never be congruent because first of all this guy has four sides, this guy has three sides. This guy has four angles, this guy has three angles. They cannot be congruent by any means. It's like you are trying to make my hands and my feet congruent. Not possible. Yeah? So, you talk about congruence with similar shapes, meaning triangles to triangles, rectangles to rectangles, circle to circle. They only can be congruent. And as Pradeep said, if you ever say or claim any shape is or any two shapes are congruent, you are saying that they are exact copy of each other. Okay? Are these two congruent? No. One difference. This guy has black cap, this has green cap. So there's one property which is not matching. So sorry for saying a blunt no, but I'm saying this is what congruence means. When you say congruent, you have zero doubt. Here we had a doubt with the color of the cap. Yeah. Same thing when you talk about any shape and say they are congruent, you have zero doubt about any of the property and every property. Everything is matching. Sides are matching, angles are matching, area is matching, perimeter matching. Okay? Two A4 sheets, paste them one after another. They are exact copy. That is what is congruent. Now, when you look at two triangles being congruent, you will say that, okay, these two triangles, I will say they are congruent if every property matches. This side matches with this side matches with this side, and this side matches with this side. Three properties matched. Okay, are these congruent yet? Probably not. They will be congruent if this angle matches with this angle matches with this angle, and this angle matches with this angle. Now we are more confident of calling these two congruent because every property matched. If the properties matched, then that means the area will be the same, the perimeter will be same. Right? Perimeter is what? That's some of the sides. Some of the sides. Since the sides are same, perimeter will match. Now area will also match. You are more confident to say these two are congruent. Okay? Is everybody with me?
Yes, sir.
Okay. Alright. So, Mandeep, you are 5 minutes early. Please join up to 5 minutes, otherwise you'll be scared of me and the math both. Okay. So one simplest approach or inference from the blabber that I've done for last 10 minutes is that any two shapes will be congruent if they have each and every property matching. Yeah, that's the most basic way to look at or prove any two shapes being congruent. Okay. But isn't that little too much? Let's say if I'm talking with respect to congruence of triangles, every time I have to match all the three sides, all the three angles, that's too much of work. That's not smart work, that is hard work. And we are trying to get into a little bit of smart work, okay, with a lot of related concepts. That is where the theorems of congruence come into picture. There are four theorems of congruence for triangles that you guys would have heard about. Tell me if this sounds familiar to everybody in the class. And you don't have to say yes because your friends are saying so. Each one of you are my responsibility when it comes to teaching things. So if there's something that you are not aware of, be as shameless as me and say, no sir, I don't remember this, I have not come across this. And I'll be very happy about it, trust me. Okay?
Yeah, I don't know this.
Okay. And sorry for using wrong words. I used the word shameless. My intent was to say that I have zero shame. If I don't know something, it's okay. Even if I'm 49, doesn't matter, I'm supposed to know everything. I'm still learning every day. So I want you guys to have similar spirit. Be okay, open and claim it. Okay, I know it, I don't know it. That's fine. So, okay. So guys, don't take me otherwise. I'm your daddy, uncle, whatever you call me. Sir, don't call me buddy. That gets too much for me to digest. Okay? But yeah. So here, when you look at these concepts, these are four theorems given to us to make our job easier when it comes to finding congruence between triangles. Okay? There's an easy way to remember this. I have recently proved these theorems for the kids in level 2. How these theorems are proven, okay? You guys don't have to struggle or deal with proving it for now. I mean, again, if you guys want to see how it is proven, everything is there on YouTube from my videos. If anybody gets interested, send me a one-on-one message. I'll send you a link for that video as well. Or if you're not able to find it yourself. But these four theorems, though they look a little cryptic, but they're not. What I said was, the easiest way to find out congruence between two triangles is every property has to match, every side, every angle has to match. That is just too much. 3 sides and 3 angles, if you have to compare every time, that's too much of hard work. These four theorems were derived, which says that okay, if you have two triangles where all the 3 sides match, meaning first side of this triangle and first side of this triangle, second side of this triangle and second side of this triangle, third side of this triangle and third side of this triangle match, they are congruent. Don't have to worry about it. Because if these 3 sides match, angles will match by default, don't even worry about it. Okay? Kids from level 1, I'm just about to wrap up this class, bear with me for 1 more minute. Second theorem is ASA. A stands for angle, S stands for side in all of this, okay? So meaning, if you have two triangles where the 2 angles match, let's say this angle and this angle matched, and this angle and this angle matched, and the side between them, the 2 angles and the side between them. So these 2 angles match and the side between them match, everything else will match. This theorem says, if you have 2 triangles where the 2 sides, let's say this side and this side and this side match, and the angle between them. So 2 sides matched and the angle between them matched, everything else will match. This is the third theorem of congruence. This one is for right angle triangles only. These 3 theorems are for every possible type of triangles, okay? This is only for right angle triangles, where if there are 2 right angle triangles, you don't have to worry about all the sides and all. If R stands for right angle triangle, so if you have 2 right angle triangles and the hypotenuse match, these 2 match, and one of the side match, meaning this side and this side match, or this side and this side match. One of them, not both of them. Okay? Then they are congruent. Our common uncle, Mr. Pythagoras. Right angle triangle. This square plus this square equal to this square, this square plus this square equal to this square. If this two matches and these two matches, the third one will match by default. No question asked. Yeah. All right. So with that being said, these were the four theorems of congruence that we just touched upon. In the next class, we'll talk about similarity and the related properties. Then we'll talk about the angles, and then the missing concepts around the right circular cone. We'll just go through it. We'll go through the volume and surface area of a sphere also, and then we'll come back to do a little more practice before we say that we are thorough with what we wanted to understand with respect to geometry. Is that okay?
Yeah.
Alright, have fun then. See you guys next Saturday. Some of you on Wednesday for pre-calculus.